Hey there. So, today I thought we could dive deep into optimizing Armstrong number verification in Python because, as an IT freshie, it's not just about knowing how to do something but knowing how to do it efficiently, without wasting cycles, The journey of understanding Armstrong numbers in Python is pretty fascinating. Let's start by crafting this function from the ground up. First things first, what we want is a function that accepts a number and tells us if it's an Armstrong number, right? The straightforward method involves converting the number into a string, breaking it down character by character, squaring each digit, summing them all up, and then comparing this sum to our original number. As we embark on this journey, we should always consider readability as a priority because we have to maintain clean code in a professional environment. Here's how you'd go about writing this function, step by step, while keeping it as approachable as possible. Python definite is _Armstrong, num_str is equal to str num_lay is equal to lay sum of cubes is equal to sum num_lay for digit in nums. Return number is equal to sum of cubes. Optimization 2. Avoid recalculating the square root for repeated calls. If you are repeatedly calling this function with the same number of digits, recalculate the square or cube roots and store them. We can then use these stored values to reduce our runtime big time, especially when we hit the same numbers multiple times. Optimization 3. Use bit manipulation for divisibility tests. Digit extraction can be costly using division and modulo operations. By employing arithmetic and bit manipulation techniques, we extract each digit much faster and avoid expensive operations, which, when in a loop, can really add up. Optimization 4. Parallel processing for very long Armstrong numbers. In scenarios where the number is super long and Armstrong numbers are less frequent, employing multiple CPU cores to parallelize the checking can make a significant difference, provided our hardware can support it. This can potentially turn a time-intensive task into something more manageable. Now, we mustn't forget best practices. We are building the foundation here, so let's stay clean and efficient using appropriate data structures, avoiding redundancy, and ensuring exception handling is baked into our logic. It's about writing code that not only works right but works smartly too. Beyond just solving the problem, we look at reliability. What if we run into flaky system calls or unexpected overflow situations? We'd want error handling to gracefully catch these exceptions and, if necessary, log them for review without causing our application to crash spectacularly. And security? Always keep an eye out for security implications, making sure we are not inadvertently creating vulnerabilities by, say, inadvertently exposing sensitive data within logs or improper error handling mechanisms. Finally, let's think about the future and how our current Python 3.x might hold up against future Python releases. We might leverage recent PEPs on performance testing and write our code with backward compatibility and maintainability in mind, possibly hinting at using NumPy or types for critical bottlenecks. After all this exploration, if we found the Armstrong number verification in Python a bit less daunting, remember to always validate your code with a suite of automated tests. We often hear about test-driven development, and for good reason. It ensures our code is robust under varied and unexpected inputs while catching any flaws or regressions as soon as they pop up. Hey, don't just stop here. Continue to refine, refactor, and optimize. There's always room for improvement. And when we're feeling nostalgic about our previous selves, let's remember how far we've come from that first naive iteration of our Armstrong number code. For all the deep dives that we've done, If you are hungry for more knowledge or just love a good tutorial, make sure to visit neeraj.qzz.io and keep your subscriptions rolling with TechLab. Keeping the learning journey going is always a cause for celebration.